There we go. Okay, I should be recording. For whatever reason, it's not recording. Then I'll just record it again another time. But all right, here we are at Overleaf. Here are all the projects that I've made so far. And you click this green button called New Project to create a new project, but I know I didn't have to say that. Here there are templates you can use. Let me just click on one, like academic journal. If I click here, there's just templates of what people have made that, you can, if you open as template, you can make edits to it. But for now, we're just gonna do a blank project. I'm just gonna call it Physics Workshop and create. All right. So here we have I'm not sure, the command console, I guess you can call it. Right here is where your document ends up being. Whatever you type here, it's going to appear on this document. This one is zoomed in. You can use these to zoom out or fit the page. I'm going to go ahead and leave it like that. And yeah, every time you open a blank project, it gives you all of this right here, all of these commands. So here, author, I'll just write out my name. There we go. Automatically gives you the date. I think if you leave this blank, I think it gives the, oh, never mind. I'll just leave it. I thought it would automatically put in today's date. I think there's a way you can do that, but you can also just manually put it in here. Then we have the begin document. So up here, you see there's a, this is where you put the title information, the author, and the date, and then it's begin document. And then after begin document, it says make title, which tells LaTeX to have these, to make sure to add these stuff right here. So here's a section. So whenever you make a section, it is numbered like that. If you put a star in front of a section, it doesn't number it, but I'll just leave that off. And then whenever you make any commands or any changes here, you'll hit recompile right here, and then it will appear here on this document. The first thing you'll notice when you open a blank project are that the margins are really small. I'm just going to type up some random stuff here just so you can see what happens. Very small. Let's see, that's enough to show. Yeah, you can see how the margins are kind of small like that. One way to do that is if you go up here, so above the begin document command, I'll add some space there. You hit, to do commands, you hit the backslash. And in order to make the margins how it should be normally, if you do the use package and type full page and then recompile, then the margins become how they should be. So yeah, if there's like changes you want to do, that's when you would use a use package. So and if you want to make a comment, you can use a %sign. And I usually like to make comments on each package that I use or anything, just so I remember what exactly that package does. And we'll see more as we go along. And then, yeah, like I said, if you do use a %sign, you can comment and it will not appear on the document. Let's say you want to skip a line. If I skip a line here, like this, if I skip a line here on the command console and I recompile, it doesn't actually skip the line in the document. It just indents the words on there. And if I skip 2 lines or however many lines, it still won't skip. The way to do that is by using 2 backslashes like that. If you do 2 backslashes like that, it'll skip 1 line. If you do it again, then it'll skip 2 lines. And I think you could just keep on going as much as you want. Yeah. Just skip lines in the document. Just use as many backslashes as you wish. Now I want to show you how to make a list of items. So let me type. Here's a list of items. So you hit backslash, and the way to do this is to use the begin command. And on the begin command, if you type itemize, right here on the item is where you would write something. So like here's the first item, and then it'll appear right over here. Let me put backslash there too. And then if you want to add more items, you would just do backslash item, and then just keep on going for as many items that you want. And you just recompile, and then yeah, they all appear right here. You can also number the list as well. Here's a numbered list. Instead of, you use the begin command, but instead of itemize, you would put enumerate. Like here's number 1. And then if I recompile, now you can see that it's now numbered. Also, I should say there's a red X right here. Sometimes you get these error messages, and sometimes they don't affect the document. Like here it says there's no line here to end. I think it's because I had this backslash. If I take it out, I think, yeah, it's like it just didn't like that. But you can sometimes ignore those. But there's sometimes where you'll get an error, but it actually does affect the document. In that case, it didn't really do anything. And yeah, again, you just click on item, and then recompile, and then right here in the document, it just keeps on going for as many long as you want. And then once you stop, then just make sure you have this end command, because without it, then it can really mess up your document sometimes. Okay, now let's do another section. So to do that, just backslash section. And right here in the brackets, you write down the section title. Here, I'm going to call it equations. By the way, the way I like to organize what I'm writing on the console command, I like to, after I make a section, I like to tab it, and then this is where I write my words. You can also do it like this too, but it all depends on preference, but I always like to just put a tab on there. There's 2 ways you can write down an equation. So like here's one way. Let me see here. One way to do it is to use the backslash. Let me see. The backslash and a square bracket, just like that. And then in between, you would write down your equation. Like here, I can write 1 + 2 = 3. And then when I recompile, it centers the equation like that. It makes it look really nice. Another way you could do it in this one, like here's another way. is to use $2 and then end it with $2. It's the exact same effect as doing this way with the backslash and square brackets. But I do prefer doing it this way because it can be easy to accidentally miss $1. Another way to do it, let's do number your equations. Let me see here. So if I go the begin command and type out equation, right here in between, I'll write down the equation. So like here, 1 plus 2 equals 3. And then here, it's like the same thing, but now it will number the equation for us. And you can actually label these equations as well. And then you can reference them later. So like right here, if after the begin equation, I put label, I just label it whatever I want. Like I'll label it simple equation. If I want to reference it, I could do it like this. So you can reference the example equation. Let me just look at my thing really quick. Use the reference command. So backslash reference and the brackets. Will actually let you know which equations you've labeled. So here, simple equation. And then when I recompile, you can see that it will bring it out. You can also just write it manually if you wanted to, and just write out equation 1. But if you end up changing your equations or taking it out, then you would have to manually relabel them all. Here, if I were to write another equation or change it, it will always be able to get it right. Let me see here. All right, let me do another section. In this section, I do want to talk about the physics package, which is a package I actually found recently, and I wish I found it a lot sooner. Because this one, you are able to do so much things with it. I'll be sure to import that in a little bit. But like, here's like an example. Let me write out the definition for average velocity. Now, average velocity defined as the following. And before I write down the equation, I'm going to go back here. I'm going to go up to above the begin document command. And I'm going to write use package physics. And I'm going to, at the end of this, I'll be sure to put out a PDF that shows you all the different commands you can use in the physics package. Let me begin equation. So just going back here, I'm going to begin the equation, and I can write fractions. So b is equal to write a fraction, use backslash frac, and then you get these two brackets here. The first bracket is going to be the numerator. The second bracket is going to be the stuff in the denominator. We can do subscripts too. So average velocity is x, and to do a subscript, use this underscore command, and then I'll do f for final, x underscript I. I'll put a space here so it's easier to see. And here I'll do t final minus t initial. Then you can see it right here. I'll zoom in a little bit. Like that. So if you do like a subscript with just one letter, just doing it like this is fine. But like, for example, if I wanted to add the subscript AVG for average here, look what happens if I just do it like this. It only puts the first letter in the subscript, So if you have more than one letter or more than one number, you have to add curly brackets in front of it. And that way it will actually put the whole word or number that you're trying to put under the subscript. And, I want to condense this equation. One way I can condense writing this is to use delta x over delta t. To do that, just backslash and then just spell out delta. And then just put a space, and then we'll give it to you like that. You do have to make sure this is an uppercase delta, which is why I use an uppercase D. If I didn't do the uppercase D, when I did the delta command, it would give me the lowercase delta. And then, yeah, always make sure to put a space, because if you don't put a space, LaTeX is going to think that's the command deltex, and then you'll get an error, and then you'll just see it disappear. So that's like an example of an error that actually does affect the document. Okay, cool. And then, yeah, if you guys do have any questions, just let me, you can unmute yourself too. You can also bold words too. Like, for example, if I wanted to bold the word average velocity, you can actually just highlight the word you want to bold. I'm on a Mac, so if I press Command B, it'll automatically give you the command for bolding, which is just text BF. And then it'll pop up right there. You can also, going back to the equation section, when you're writing these equations, it's called math mode. You're in math mode. You can actually do equations within a sentence. The way you would do that is with just a $1 sign in the front and at the end. Like here, there were $2 signs. Here, it's just one. And let's say if I put a V there, and then we see it puts basically like a small equation there. So if I wanted to do V average, just like that. The only thing is that you can't bold anything. If you want to bold something in the math mode, you can't use this text BF command because it only bolds math. It only bolds text. To do that, we need another package. So I'm going to go back up here. And the package is called BM. And let me write down the comment here. Allows you to use boldface math mode. So the command is just, once you get that command there, it's just \BM and then put a bracket on the entire thing you're trying to bold. And now we see that it's bolded there. All right. Now let's get a little bit more fancier. Let's talk about velocity. We can obtain velocity by letting, and then I'll go in math mode, delta t approach 0. To get this delta t, you have to be in math mode, because if you don't put it there, it really affects everything, because this command delta, the Greek letter commands, are all supposed to be commands you would do in math mode. And then you can see it kind of affects everything here. You just have to be sure, do that here. I'll just do begin equation. Let's do a limit. So to do a limit, let me look at my notes here. It's just \LIM. The way to do this is that you do an underscore, and then we'll do the curly brackets. So then everything that's in here will be under the limit. And we want the limit of delta t going to 0. So we'll put delta t here. To get the arrow, we just use \right arrow, just like that, then 0. And then when I recompile, you can see we get the limit right there with the delta t, right arrow 0, just right underneath it. So then I'll put in the rest of the equation here, delta x, delta t. But of course, one way we can just say this is just by dx over dt. And with the physics package, you can actually very easily get the derivatives like that. The command for it is \dv, and then 2 curly brackets. I'll put the x in the first one and the t on the top one. And then when I recompile, it'll give me dx over dt.
Can you ever use, what is it? I wanted to call this MATLAB LaTeX. Can you ever use LaTeX as a calculator or only as like a software or document software?
I don't think, I don't know actually. I don't know if there's like a package or something you can do where you can do math on here. Um, but that is an interesting question. But yeah, to that answer, I have no idea. All right. So acceleration is the second derivative of position with respect to time. One way to do that is just to use the same command as before, dvx and t. But right here in between dv and the first curly bracket, if you put a square bracket in there and put the number 2, that will indicate the second derivative. So let's see. And then, yeah, I should also say that you don't need to, LaTeX will automatically put things on a new page for you. So here, they ran out of room, it went on to the next page. And then we see now we have the second derivative. So you just have to put that square there.
I have a question.
Yeah.
If you don't want the x and the t to be italicized, is there a way to remove that?
There might be a way. In the physics package, all the commands that you can do, there's a whole bunch of like different things you can do. And I think there's a lot of different formats you can do it as well. So I think if you look at that, there might be a way to do that. You can also do integrals too. So yeah, a lot of these things are pretty straightforward, which is nice too. You just have to kind of get used to it. So like for the integral, let me see. The command is \int for integral. So like let's say I wanted to do the integral of 5 with respect to x. We use \ddx. And then when I recompile, where did it go? Here it is. And this is how you get that dx there, just that. Instead of a v, instead of dv, it's dd. This, of course, is equal to 5x plus a constant. And you can also box your equations too. So if I use the command boxed and just put a curly bracket over everything I want to box, I'll box it for you. Now, if you wanted to do an integral that had bounds in it, it's almost the same thing, except now you use an underscore and you put whatever you want on the bottom. So let's say I want to do 0. And then you use I think this is called a caret. But you know what you would use for like as an exponent, then you would put in the upper bound. So here I'll do 5. And then I'll do the same as the previous one. There you go. Now I have the bound 0 to 5.
Could you try doing a lower bound with a subscript on it? So would it just be like 0 or like underscore 0 or v underscore 0? And would that be v naught to fly?
Oh, okay. Let me try that. Yeah, so I think to do that, you would need to use a curly bracket because you have to use a curly bracket if it's more than one word. Let me try that. So I'll put v underscore 0, and I'll change this 5 to v. There we go. Yeah, now it goes from v naught to v.
Nice.
So you would use an underscore, then curly brackets, and then v underscore 0, and then you're good to go. And there's a way you can, let me look at my notes here really quick. So if you want it to be like extra fancy and have like the evaluation bar after you do the integral, use the command eval, put a bracket of what you want to evaluate. So here, 5x. And then you would pretty much just copy and paste this part right here that you put in the integral from the bounds. So right after eval of what you're trying to do, just copy and paste, and then you'll see, and then you get this bar right here. All right. You can also do vectors as well. So we can make a vector, and you can make a unit vector too. It's pretty straightforward and easy too with the physics command. So to make a vector v, the command is \va, and then in curly brackets, and then whatever you want to be in your vector. So if I put v here, it gives you a bolded vector with an arrow on it. And if you look through the physics command pages, there are a whole bunch of different formats you can do. I think there's one where you can have this not bolded or just an arrow. I think there was one where you can take off the arrow, but I don't remember what that one was. You can also do, like I said, the unit vector, which is almost the same command, but instead of VA, it's VU. So I'll put like an I there. So now I have a unit vector there. So let me write out the position vector. Position vector. So VA R equal to X VUI.
What shortcuts are you doing to make the equation brackets and backslashes pop up more quickly?
Okay, yeah. So right here, like I type in VU and I see that the command is up there. So I just hit enter. And then when I hit enter, it'll automatically put my cursor into the brackets.
And so
Yeah, so like right here, then I'll just hit enter. And then just like that. Oops, let me make that J and K. There we go, just like that. Little nice position vector there. All right, we can even do dot products and scalar products too. I'm gonna make this a begin equation just because I feel like it. So let's say you wanted to do A dot B. So you do VA A. The way to get the dot, there are a couple ways you can do it. One way is to use the C dot command. This will give you like a center dot. Just like that. Another way you can do it is be more explicit if you wanted to and call it dot product. And then it'll give you the same thing. It looks like with dot product, it does make it a little bit bigger, more noticeable. Another thing you could do with the physics package when you're in like an equation, if you use \QQ, in the brackets, you can write text on here. So that's one way you can put text onto math mode, because if I were to add text here without anything, like let's say I wanted to do va.vb and I wanted to show the cross product too. I'll just write out cross product here. I have that text and here, but when I recompile, you see it gets all messed up there. One way to do this is you could use the text command, but when you do that, it fixes so it's not italicized, but it's still squished together. And you could add spaces too on both sides if you really wanted to, but you can get more space by using the QQ command. So if I put QQ, and then if I would put and here, it'll automatically put like the spacing around it, just like that. That's one of the easiest way to put text on there. And then there's a whole bunch of equations that you can write out. Like let me write trig functions. You just backslash sign. You can use curly brackets x. Cosine of x. Up here, right here. And then if you use a QQ command and you don't put anything in the curly brackets, it'll automatically give you a space. So that's one way you can spread out some equations like that. Like QQ, all right, tangent of x. You can have cosecant of x. You can even have like hyperbolic functions, so sine h of x. Or let me get crazy here, maybe, oops. Hyperbolic tangent of 5x plus 32. And then if you wanted to put parentheses, you would just put the parentheses right in here in the curly brackets as well. And you can also do logarithms. So you can do log of 5. If you want to put, let me see what that shows. If you want to put like a base here, let me see how you would do that really quick. I think you would just use an underscore. So like log base 2 of 17. And I think it should give you, yeah, so you would just use like an underscore. And then of course we have the natural log, which is just ln. ln of e equals 1, just like that. And then you can do exponents too. Let me put the exponents here. And again, after this workshop, I'll put a whole list of the commands I've been using, and I'll give you guys like a problem set template that has a whole bunch of math commands on there too, so you can always look back at them too and see how to do it. Yeah, exponents is pretty easy. So like if I want to do x squared, I'll just type in x caret squared, and it pops up. If, for example, I wanted to make something that was longer than like one letter or one number, like x to the -2, I couldn't just do x caret -2 because it's only going to put the minus in the exponent. So that's when you would have to use the curly brackets. And then I'll go back up. And like if you wanted to do like e to the something like e to the 5x. There we go. Let me do a longer one. Like I can do e, to do a square root, it's just backslash sqrt, and then everything in the brackets you would put in, so like the square root of 5x plus 3. And there you go. I can make it even more complicated. Maybe I could put like a sine of x squared. And there you go. Sometimes I put spaces in between these brackets, like this one. It really depends on your preference, whatever makes it easier, just so you know which brackets are going to which function that you're doing. But like if you wanted to add spaces to them to distinguish, then you can. Let me see. I'm going to skip some stuff. I want to talk about tables because I know tables can be a little bit tricky to do on LaTeX. When I do tables, there's a command, there's a package I use because it makes the tables look a lot better. So let me go back up here. I use a package called book tabs. Better looking tables. Book tabs. Okay. Let me make a new section here. Oops. And then yeah, I'll have tables on my example sheets too, so you can look back at them as well. So to do a table, you just do the begin table command, and it kind of does like everything for you. So begin, write table. I hit enter. It will give you all this stuff that you need. And let me see here. Begin. So like right here, let's say these C's stand for column. So right now this is a 2-column table. So if I put like cars and trucks, I don't know, chocolate and vanilla. I can't think of anything right now, but chocolate, spelled it wrong, who cares? If I recompile, where to go? Let me see, is there a missing backslash here? Oh, interesting. I think I need to put it in a different command here. Let me see. Oh, wait, let me see. I think it, okay, that's right, yeah. Sometimes these tables and also with figures, they don't go where you expected them to. Like I forgot to do this. I was expecting it to be under the table section because that's where it is on here, but it brings it all the way up here. One way to make it exactly where you want it to go is to use the float package. So let me go back up here again, and I use a package called float. And that gives you more control of where you want your table or images to go. And right here in the square bracket after begin table, if you use the capital H command, it will force it to bring it down exactly where it is, like in the console command. There's a whole bunch of different float commands you can use too. That's the one I like to use. And yeah, so this is how the tables normally look like. If I were to take out this, you can see between these two C's, there's this vertical line here. If I take that out, it will just take out this vertical line right there. And if I wanted to make a new command or a new column, you would have to make sure to add another C here. And then you separate them with ands, with the ampersand and. So like trains, we can go here, and then put another and here. Let's see. And of course, if you want to add more rows, you just keep going as much as you want to go. For random stuff here, just so you can see the idea. You can label and caption here if you want to. Here's my table. If we remove them, I'll just take out the the captions that you have there. But yeah, the books tab package, the one that I put here that says it can make better looking tables. When you have that package, you can also do this. You can use commands called like top rule. And it'll give you like a top you can do there. You can do like bottom rule. It gives you a way for you to add horizontal lines. I can even like go right in between here. And if I use mid rule, and then I can go down here again and use mid rule. Oh, whoops. Just like that. Just add as many as you want. So you can make tables as many rows down as you want by just taking this process down, add more columns by adding more C's here. And that's basically how you make a table. Any table that you wish.
How do you add vertical lines?
So you go back here where these columns are and add the vertical line. So just like that. So if I put one there, there should be one between the first two columns. If I add another one right between these two, it will give the other column. Just like that. Let me see, if I put it before it, will it do it? Okay, cool, yeah. So just like that. Cool. Let me see. I'm running out some time, but one thing I do want to show. Let me make a figure. So let's say you want to put a figure on here because tables and figures I think are the hardest ones to do. It's almost like the same. So just begin figure. Right here, include graphics is where you would put your image. What you have to do first, you go right over here to this side. You click this upload and select from your computer. So there was an image I was going to use. I don't know if I think it's on my desktop. No, I'll just put my school schedule. That's a PNG format. So yeah, I uploaded my school schedule here. Now you know all my information. I think the formats can be PNG or JPEG. There's like a lot of formats you can do. So right here, instead of include graphics, you'll title it exactly the name of this. If you want to rename it, just right click and then hit rename. So I'll just rename it as schedule. But then when you rename it, you have to make sure to rename this part here too. And see, it pops up right here. And if I hit recompile, it's going to do the same thing as a table where it kind of disappears. I don't know why I didn't. Oh, okay. Whoops, I forgot something. To insert images, you actually have to insert a package. So here's an example of what happens if you try to do something without the package. It'll give you an error and then LaTeX gets confused and then you get something like this where it doesn't show anything. So going back up here. So now you can see why there's these packages. It lets you do things that you need to do. Graphics. So now if I recompile, it should work. Let's see. Here it is. And it's really, 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 really big. One way to resize it, the way I normally resize it, because it's the easiest, right here in include graphics, I add these square brackets, and if I type out scale equals, let's see, 0.5. And let's see how it works. Let's see. There it is. Let me zoom out here. Just like that. And yeah, again, just like with the table, it'll kind of format it in a way that it thinks is the best way of formatting it. But after begin figure, if you put, like the H command, the capital H command, it'll put it exactly where it should go. It just didn't fit. It's on the next page just because it can't fit it in this space right here. But here, if I make it smaller, let's try 0.3. There we go. Really small image, but you get the idea now. So yeah, figures are can be a little bit tricky sometimes to work with. Let's see. I think the last thing I'm going to talk about, I was almost able to finish everything, but when you see the document I uploaded, you'll see the other stuff, and it's pretty straightforward. Because this one I'm going to talk about units, because when you're doing like your physics homework, this is something you're going to be using a lot, and it can be kind of tricky to put units into your equations. Like, let's see, adding units to like, let's say I wanted to add 5 meters plus 3 meters, which is 8 meters. If I type that out, here it is. Let me zoom in. It's just like the problem. It can't really do text on here. Even if I put spaces here, it's not going to make a difference at all. Let me get these errors here. One way you can do this is by using the text command that I mentioned before. So 5 text meters plus 3 text meters. And then you can see it looks better, but they're squished together. So you add the space just right here. And just like that. However, I actually made a command. I made a unit command. I'm going to type it out here. You can actually make commands on here. I made this one a while back ago, and I honestly don't remember how I did it. One day I just had enough time to try to figure it out. Right here, I'm just going to type it out, but it's already going to be on the thing for you. But yeah, basically after I make this command and I put it here, now I can use the command unit, and it makes it a little bit easier for me. You can use it if you want. When you see the documents and the codes that I'm going to give you guys for you to copy and paste on LaTeX, you'll see it there. I just want to show you how it works. And if you don't want to use it, that's fine. Just the way I prefer. Now I just use unit and then meters. It makes it a little bit quicker because, well, let me do this first. And then here, I don't have to add the space because the command that I made already took the space into account. So that's like one thing that makes it a little bit easier. Getting the unit command is also quicker too, because if I do \u and it's already there. But if I try with text, I have to write out the full word. But yeah, it's all just preference. It gets a little bit tricky though, for like things like acceleration, where the unit is a little bit more complicated. So like 20, let's say I wanted to do meters per second squared. If I do it like this, it's going to give me problems because, yeah, I don't know. It looks really weird what's going on here. It's because technically this caret symbol, this exponent, has to be in math mode. But since I'm doing this in the unit mode, this part right here, even though the unit command is in a math mode, all the text right here in the unit command is considered text. So then you would have to insert a $sign here to cover the whole exponent. So $, caret 2, $. And now it works out. So those are just some things can be a little bit tricky. Like, let me do one more. So like work is 5 unit newtons times 3 meters. Just like that. And like if I wanted to call it a Newton meter, you could do it like this if you wanted to, but if you wanted to add the dot, so like if you wanted to do C dot for it, again, it's going to give you a problem because it's C dot is a math command. So you have to put the $ C dot meter, and then I'll actually give you the way it should look. And I've looked for a long time to see if there was any easier way of doing these types of units, like meters per second squared, the ones that get really complicated. For me, this is the most easiest way I was able to come up with, just defining a command and doing these $. I have yet to find like a package or anything that makes it look really nice. Other than that, I think that's all. Yeah, that's all I have to say because I am running out of time and I do have another class. But if you have any questions or want to see anything else, just let me know. I don't mind being like a few minutes late to my next class. But if you have any questions, I'm open to listen to them.
Thanks, Sean.
You're welcome.
Yeah, man, this was so informative. I really appreciate you taking the time out to make this available to the body of the physics department.
Yeah, you guys are welcome. I actually didn't think it was going to take this long. There were only 2 sections that well, you know what? Let me just do it really quick. It's not going to take too long. Unless you guys, if you guys have to go, that's fine, because again, I'm recording this. I just want to do one thing really quick, because it was kind of, it can be really helpful sometimes. The cool thing is that down here, this is something I think that's new, but like it lets you know where all your sections are. So if I want to go to the equations section, there I am, all the way up there. Sometimes you'll get, if you want to use parentheses, like let me type out something kind of complicated, and I want to multiply them together. This is also going to be on the thing that I'm sharing you guys. Like, let's say I want to show that I'm multiplying these 2 kind of complicated equations by using parentheses. You can see that the parentheses don't go up as they should for both of them, but this one's a lot more noticeable. The physics package actually has a really cool thing you can do. Let me just copy and paste it. The only thing you need to add is just one command. If I go to this first parentheses, \QTY, it'll automatically adjust the parentheses to fit the height. And if I do one right here too, QTY, and you always do it in front of the first parentheses, it will take care of the second parentheses. So just like that. And you can also do square brackets. So like if you wanted this to be a square bracket, it'll automatically adjust the size. You just have to make sure that you have both of them, the beginning and the end. Like if I take out the last parentheses, I think it messes up. Yeah, it gets confused. So you have to make sure you do have the parentheses on both sides so it doesn't do that. And then one last thing I want to do is, let's say you're writing an equation during a sentence. So like, let me see here. Here is my favorite. I'm going to make it complicated. I'm going to do a sum here. One last thing. So like right here, I added a sum in between a sentence, although because it's really large and complicated, it doesn't really, it shrinks one way to fix this is if you use the display style command, display style, and then you right before your equation, it will force it to be the size like its actual size, and it won't shrink it. And of course, this is a preference if you want to do that. Okay, but yeah, that's actually everything I wanted to show. Since I have a class right now, I'll upload this stuff and a whole bunch of other useful stuff onto the LaTeX workshop right after that class is done.
Sounds good, brother.
Any last minute questions before I go?
How come you're such a baller?
I wish I had an answer to that, but it's just one of the most unsolved mysteries.
You know, you can't always explain natural talent.
I appreciate that.
All right, man. Have fun in your class.
All right, thank you. All right, see you guys. Let me stop my recording here and then I'll be good to go.